Okay. Um, I'm losing track of how many parts this is. I think this is part 4 of our review. But anyway, this video is part of a review of our Introduction to Polynomials unit. And we've done a bunch so far. But now we're going to work on factoring. And specifically, this video is all about factoring trinomials. Okay, so let's practice factoring our trinomials. Problems like these. Alright, the first step of factoring is to look for the GCF. And while all of these are divisible by 2, they're also divisible by 4. So we need to go with that. And variable wise, I see the x squared. They all have at least 2 x's. So the GCF is going to be 4x squared. So that's what's going to come outside of the parentheses. Now, as far as what goes inside the parentheses, you should be thinking in terms of dividing by your GCF. So I have 4x squared, so I'm going to divide everything by 4x squared. Okay, divide by your GCF. And that's how you do it. So that means on the inside, 4 divided by 4, they cancel out, so no more 4s. X to the 5th power divided by x squared, that's going to be x to the 3rd power. Okay, just real quick, when I say that, when I say x to the 5th power divided by x squared, in your mind you should be picturing x to the 5th power is 5x's. X squared is 2x's. So when I say, oh, these are canceling out, this is what I'm talking about. The 2 x's in the bottom are canceling out 2 of the x's in the top, and that leaves behind 3. That's why it's x to the 3rd. And you could say, oh, well, you're just subtracting, but this is what's really happening, and the more you think about what's really happening, the fewer mistakes you'll make, okay, because you'll understand the big picture. Anyway, so 20 divided by 4, that's 5. X to the 3rd power divided by x squared, that's x. And 12 divided by 4 is 3. And the x squareds cancel out completely. So I guess I don't need that much space. So that's why this is the answer. You should take a look at this and see if it can be factored, but I see I have x to the 3rd power. This is not going to be factorable. If this were x squared, I would at least think about it, but 3 times 1 is 3. There's no way to get 5 out of it, so this is it. Alright, let's move on to number 15. Again, the first step is always to look for the common factor. Well, number-wise, -3, 15, those are both divisible by 3. But this term doesn't have any number here, so I can't divide by 3. However, we don't like to leave a negative in the front. So if you have a negative in the front, go ahead and factor out -1 as part of your GCF. Okay, don't leave a negative on the inside of your parentheses as the leading coefficient. Now how about the variables? I have x to the 4th, x to the 3rd, x squared. Okay, the lower amount here is x squared. So let's go ahead and pull that out as part of my GCF. Now how about the y's? I got y squared, y, and y squared. The lower amount is the y, so I can pull out a y. Let me drop this down just a little bit. Okay, now that we have these other things, the x squared and the y, we don't need the 1, so it's just negative x squared y. So this will be our greatest common factor. So again, anytime you have a negative number as your leading coefficient, you're always going to want to pull that negative out when you factor. Okay, so again, to decide what goes on the inside, we are dividing by the leading coefficient. So we are dividing everything by negative x squared y. Okay? So, since we're dividing by a negative, all of these signs are going to change. So, we will have a positive 3. Now, these two x's will cancel out two of these x's, and I will have x squared. This y will cancel out one of these y, so I'll have y. Okay, so 15 divided by negative 1 is negative 15. These two x's cancel out two of these x's, and that leaves one x. These two y's cancel out totally, so there will be no y's. Okay, a positive divided by a negative is a negative. These two x's cancel each other out, and this y cancels out one of these y's, so I will just have y. So let me tighten this up a bit. And that's it. There's nothing I can do with this as far as factoring further. So this is going to be the final answer. Okay, problems like number 16, especially because the leading coefficient is 3 and not 1, because there's a number here. This is one of the most commonly missed problems every year. Students that learn the product sum method or whatever this is, I don't know what it is, but you know what I'm talking about, students that use this method and put stuff in here. Bow tie method, I hear people say. It takes more than just knowing what multiplies to this and adds up to that. It takes more than that. There's an extra step to it that half of you forget. And now I can't tell you what that extra step is because I don't use this method. But just be careful. I'm going to show you how I do it. And if you're doing your bow tie method or whatever and you're not getting the same answer that I'm getting, you better either go back and find someone who knows how to do your method properly, or you better just learn my method. So here's how I do it. First, I look for the common factor. There is no common factor, so let's move to the next step. When we're factoring a trinomial, it's quadratic. You can bet it's going to factor as a binomial times a binomial. Okay, so first we start with the first term, 3x squared. 3x squared can only factor as 3x times x. Alright, this is a prime number, so that's our only choice. Okay, next we look at the last term. Don't worry about the sign yet, just look at the 4. 4 has two possibilities. It's either going to be 2 times 2, or it's going to be 1 times 4. Okay, so here's where we do a little bit of trial and error. We can't just immediately look for the middle and go, oh, which one of these can add up to 1? That doesn't work when you have a number in front, guys. That's the problem. So let's just do a little bit of guess and check right now. It's not that bad. So let's start with 2 times 2. I always start with the lower numbers first, and then I move up to the higher numbers later. Okay, so 2 times 2. Now here's the key. I'm going to write this down over here in orange for some reason. Inner plus outer has to equal the middle. Okay? You should always check this. Even if you do the bow tie method or whatever, when you get your answer, you should check to make sure your inner plus outer equals the middle, because that's the key. Alright, so inner, I have 2x. I feel like, let me use a different color. Inner, when I say inner, I'm talking about these. So that's 2x. Okay, outer, I'm talking about these. I'm multiplying here. Okay, so this is going to be 6x. Okay? Now, the inner plus the outer have to equal the middle. When I'm talking about the middle, I'm talking about this, including the sign. I need a positive 1x. Now, is there any way that I can get a positive 1 out of 2 and 6 if I pick the signs right? No. The smallest I can make is 4. So that means this is not working. Okay, so that means the 2 times 2 option is a fail. So we'll move on. So make sure you're doing this in pencil. Okay, so we'll move on to the 1 and 4 option. Now it matters whether we go 1, 4 or 4, 1. So either start kind of doing it in your head or just put it in and see what happens. So say if I put the 1 here and 4 here. Well, inner I'm going to have 1x. Okay, outer I have 12. Okay, yeah, that's no good. 12 is too big. Alright, I could get to 11. It's the best I could do. So I guess I should have gone the other way. And as you get comfortable with this, you'll start to do some of this in your head, and so you'll get to the answer very quickly when you get good at it. Alright, so now inner I have 4x. Outer I have 3x. Okay, again, the inner plus the outer must equal the middle. So 4x plus 3x, I have to make that equal 1x. So I need to change the signs. What do the signs need to be to make positive 1? I need a positive 4x and a negative 3x if I'm going to get a positive 1 out of it. Okay, so positive 4x, you say, there's my positive 4. And to get my negative 3x, this 1 would have to be negative because that's the outer where it came from. So there's one last thing that we have to check before we put a box around this and call it the answer. We need to check the sign of the constant term. So does positive 4 times negative 1 really give us negative 4? And yes, it does. A positive times a negative is a negative, so this is the answer. But don't gloss over that. A lot of kids are ignoring me on that. Sometimes we get the correct middle, inner, outer, middle. This is all good. But when we go to look at it, we're not getting the right sign on the constant term. So if that happens, you have to throw out that answer and keep looking. But for now, we're good. So we'll put a box around it and we're done. Okay, let's move on to number 17. What is the first step of factoring, people? This is so important. First step of factoring is to look for the GCF, greatest common factor. This problem has one, so you will be wise to make sure you pull out the greatest common factor. 3 divides evenly into all of these, so you really want to pull out that 3 before you do anything else. Let me make the 3 a different color. Okay, so leave that 3 out there. If you divide everything by 3, that's going to give us 2x squared plus 5x minus 12. So now we're going to factor the trinomial shown here in blue. We're going to factor this like usual. Okay, but we're going to keep this 3 out there. Alright, so let's do our process. 2x squared, alright, you look at the 2x squared first. 2x squared can only be 2x times x. Okay, now you hop over and you look at the 12. 12 has several options. Alright, 12 is either going to be 3 times 4, or 2 times 6, or 1 times 12. There's 3 possibilities. Again, we cannot just look at these pairs looking for the 5. as you notice, none of these actually make 5. So some kids start thinking, oh, it's impossible, it's prime. No, it's all about inner plus outer equals middle. So for now, just pick one. So I'm going to go ahead and start with the 3 times 4 option. Okay. Now, shortcut, people. It matters whether we put the 3 here and the 4 here, or whether we put the 4 here and the 3 here. But one of these options is impossible. Before you even think about it, you should know that it's impossible. And this is the option right here that is definitely not going to work, so I wouldn't waste time on it. I would throw out this option. Here's what I'm talking about. Look inside the parentheses. Do you see the common factor here? Both of these are divisible by 2. Okay? If there's no common factor in the original expression, there should not be a common factor inside your either set of parentheses. So we already pulled out the 3, so there's no common factor here. So there shouldn't be a common factor here. So that saves me so much time because I know I don't have to even try 4 times 3. I will go straight to 3 times 4. Okay? Also, I'm just looking ahead. Look at let's say that somehow the, whatever. All right, look at the 2 times 6 option. What can you tell me about the 2 times 6 option? I'm hoping, based on what I just told you, you can realize at a glance that it can't be 2 times 6 no matter which way you do it. If you go 2 times 6, you have a GCF. Alright, both of these are divisible by 2. If you go 6 times 2, well, that's still a GCF. Both of these are divisible by 2. Now, we happen to start with the 3 and the 4, but I'm just trying to show you the power of this shortcut here. You can eliminate that option completely. So if you realize that, it cuts the time that it takes you to do these problems in half. Okay, so we go straight to 3 times 4. Okay. Now, so here's the key. In orange, inner plus outer must equal the middle. Okay? So when I say inner, I'm talking about these. When I say outer, I'm talking about these. Okay? So inner, I have 3x. Outer, now I'm multiplying now, not adding. So outer, I have 8x. Okay, inner plus outer equals middle. So I'm now trying to get the positive 5x middle. Is there a way I can get positive 5x out of 3x and 8x? Sure, if I choose the signs to be negative 3 and positive 8, that would make 5x. So there's my negative 3, and making this 4 positive, because it's outer, that will make my positive 8. Okay? Now there's, so that's great. This looks good so far. Now there's one last thing we have to check before we put a box around this and call it the answer. We have to make sure we're getting the right sign on this 12. Does negative 3 times positive 4 make negative 12? Well, yeah, a negative times a positive is a negative. So that means this is in fact the correct answer. Okay? Alright, now let me point something else out to you. I mean, that's the answer. This problem is done. But based on mistakes I've seen students make in the past, many students will just start factoring this without noticing that there's a common factor. Alright, no matter how many times I say it, it's going to happen. Alright, sometimes you're going to just not notice it. So I need to show you what happens then. So some of you, if you did this problem by yourself and you didn't notice the 3 at first, here's one answer that you would have gotten. You might have gotten 2x minus 3 times 3x plus 12. Okay? So say if you got this answer, if you multiplied all this out, if you FOILed it or double distributed it, it would get you back to the original problem. So it's not that it's wrong, it's that it's not finished. Okay, and the problem is here. If you look at this set of parentheses, notice that both of these are divisible by 3. So there's a GCF in here, so it's not done. You don't have to start completely over though if you don't notice your GCF until the end. You can still just pull it out now. Okay, you can bring down the factor that's fine, the one that doesn't have a common factor in it. And right now, if you notice that these are divisible by 3, you can take that 3 and put it out front. Okay, so there's your 3 right there. And then now that you have taken out that 3, divide by 3, this becomes x plus 4. So then you see you still get what we had. Okay, so just watch out for that. Even if you don't notice the common factor in the original problem, if you accidentally go ahead and just do it, maybe you'll notice the common factor in your parentheses in the end, and you still need to, you can just take one extra step and still pull it out. The other answer that you might have gotten if you didn't pull out the 3 in the beginning is you might have gotten 6x minus 9. And you can probably see where I'm getting this from. If I took this 3 and I did the distributive property, I would get this. So maybe you had 6x minus 9 and x plus 4. If you got this, it's not that you're wrong, it's that you're not finished. And again, the problem is right here. You have a common factor. You have to pull it out. So again, you would just, to finish up the problem, you would bring down your x plus 4. You notice that these are divisible by 3, so bring that out and go ahead and write what's left once you divide. So that would be 2x minus 3, which brings you back to the same thing that I had. Alright, this video is getting too long, so was this number 17? What's next here? Okay, we're still factoring, but now we're factoring binomials. So we will end this video now, but when we come back on the next video, we will be factoring binomials.